Hey everybody, we're going to do 7.4. So 7.4 is kind of a small section about how to approximate binomial to the normal distribution. And that was something I said in the binomial lesson about how using that formula, the n choose x, p to the x, and then 1 minus p to the n minus x, that's to find the probability of exactly x out of n happening. But let's say you want fewer than a number or more than a number. Then you got to do this for each exact number that you got. So we're going to be doing this and then doing it again for a different x, and then doing it again for a different x, and so on until you have all of them added up. That takes a long time. But instead what we can do, since this is the probability of x equal to a number, little x, this would be the probability that x minus 0.5 is between the number we're looking for and x plus 0.5. I know this is kind of confusing. It's all in like different blah, blah, blah stuff. But what I'll show you in this examples that might help is that in order to approximate, we have to think about the fact that we're adding 0.5 or subtracting 0.5 from the number they're giving us because we want to look at a continuous continuous variable versus binomial, which looks at a discrete variable. So discrete variable goes into whole numbers and continuous variables have decimals. All right, so with number one, you have 48 questions. So n is 48. That's the total number of questions. And this person is just guessing, which hopefully that's not what you're doing on the quiz. The probability of getting it correct, it's 1 out of 4, right? There's 4 answer choices and 1's correct, so that's 0.25. Okay, so what we want to do is we want to find the probability of getting exactly 15 correct answers. I don't know why they're looking for that, but they are. So in this case, like I said, if we're looking for exactly 15 instead of all that business, we can say the probability that our normal distribution is between 15 minus 0.5, which is 14.5, and 15 plus 0.5, which is 15.5, like so. So what this does is that it creates two z-scores that we can look right in between, and 15 is right in the center of it. And we can approximate that area to the area under the binomial distribution curve that matches. Okay, anyway. So, I need a z-score in order to use the chart, remember, from the last lesson? And the z-score needs a mu and a sigma. Well, in binomial, we had formulas for that, and that was n times p for mu, and that was the square root of n times p times 1 minus p, right? So in our case, our mu is going to be 48 times 0.25, and that is, what is that? 48 divided by 4 is 12. That's our mu. And then our sigma, I'm going to have to use a calculator for, and that is... Come on, I got a new calculator now. Not a new, it's somebody else's phone. Okay. So we get n times p, which is 12, and then we're going to multiply by 1 minus p, which is 1 minus 0.25, so 0.75. And that's going to be equal to 9. And don't forget, we got to take the square root of 9 to get 3. So there's my mu, there's my sigma. And with those two, I can find my z-scores. Now, there's two of them to find. One of them is 15.5 minus the mu, 12, over the sigma, which is 3. Okay? So we get 15.5 minus 12 equals, and then divide by 3, and that is 1.167, which rounds... pin to 1.17. For z-scores, you want 2 decimal places. The other one is 14.5 minus 12, and that's all over 3. So let's do that. 14.5 minus 12 equals, divided by 3, is 0.83333333, which rounds these 2 decimals. Okay, so we have 2 z-scores. And if you remember from a previous lesson, what are you doing over here? Okay. that whenever we want to find the probability in the normal distribution, binomial, normal, that we find the probability of the bigger one, subtract from the probability of the smaller one, if we're talking about left side, which we are. So, probability that z is less than 1.17 minus the probability that z is less than 0.83. So then we go to the chart. They're positive z's, so let's go to the positive z chart. There we go. And then we want 1.17, so 1.1. Let's use the cursor. And then let's go over to 0.7. Is that right? Oh, you're not here. 0.8790. Okay. And then we go 0.83, so 0.8. Use the cursor. 0.8, and then we're going to go to the 3 column for 0.83. We get 0.7967. 0.7967. And we subtract those two. And we get, what do we get? What do we get? What do we get? I don't know. You tell me. I got a calculator. Hold on. We got 0.8790 minus 0.7967, and that's 0.0823. That's my favorite number. Maybe. Let's check. Let's go down to the answers. Yep, we got it right. Woo! Okay. That's how you find exactly using a normal distribution. And number 2, which is much more useful of a thing to do, and that is to find it when it's fewer than. So let's first of all, let's say what n is. How many? We got 150 advanced reservations. And then our probability of having a no-show, which in this case is a success for our purposes, even though in real life you might not want to call this a success if you have a no-show at a restaurant, is 0.15, 15%. And then, of course, because before I had to find mu and sigma, I can go ahead and do that. But if we want to go right to the source, right to the problem, let's look at what we're saying. We want the probability that we have fewer, so that x is fewer than 20. So like this is not on the formula sheet quite like this, okay? So I put up some examples in the formula sheet. And that is, if you want to include the number, then you have to go a little bit past it before you go left. So that includes the number that you need to include. But in this case, when it says fewer than, I don't want to include 20. I don't. So we're actually going to make this the probability that x is less than 19.5 for normal. So this is the binomial, and this is the normal approximation. Norm! It's a Cheers reference. All right, so 19.5 is the number I'm going to be working with. Now I can find my mu. Now I want to find my mu. How about that? So 150 times 0.15 is going to give me something. Delete. 150 times 0.15, 22.5. Okay? And then sigma is going to be the square root of 150 times 0.15 times 0.85, right? This one minus p. Sorry, so sloppy. And that gives me the square root of something times 0.85. Square root of 19.125. So square root of 19.125 is 4.373. And they say in the problem, round the standard deviation to 3 decimal places. So there you go. Those are my two. With those two, I can find my z-score. And there's only one to find in this case. Yay, 1. 19.5, which is x, minus mu, which is 22.5, divided by 4.373. And that is going to give me, oh, dang it. My calculator keeps going away on me. 19.5 minus 22.5 is 3, negative 3, equals. And then divide by 4.373, and we get negative 0.686, which is 0.69. When we round, remember z-scores, 2 decimals. Okay, so now all I gotta, since it's less than, all I gotta do is find the chart number for that. So the probability that z is less than negative 0.69 is going to be equal to, let's look at the chart together. Right? Oh, negative numbers, so I need this chart right here. Okay. Negative 0.69, go all the way to the edge, and you get 0.2451. 0.2451. And then I check my answer. Yep, 0.2451. Okay, so put a little box around that, I'm all done. So if it's fewer than, you don't want to actually include 20. So that's why you subtract 0.5 from it. But if it said less than or equal to 20, if it says less than 20 inclusive of 20, or some English word like that, then we would say x is less than 20.5, because we want to include that number in our normal approximation. Okay? So it just kind of depends on what they say, what the words are. And here, if it's an exact number, it's always subtract 0.5, add 0.5, and find what's in between. I'm not sure that this is less work than this would have been. But, you know, it is what it is. It be like that sometimes. Number 3, this is the last one that's so, work intensive. The last 4 problems on this worksheet aren't so bad. But for number 3, it asks, a salesperson found that there's a 1% chance of a sale from her phone solicitations. 1 out of 100 people say, sure, I'll buy something when she calls them. What is there in? 1,000 telephone calls. So this person makes 1,000. Can you imagine calling 1,000 people? I don't even like to call my family sometimes. Anyway. And we're going to say the probability of success is 1%, which is 0.01. Okay? And then it asks us, find the probability of getting 5 or more sales per 1,000 telephone calls. So the probability is x is greater than or equal to 5 for binomial. This is the binomial one. So if I want to change it to norm, then I need to include this 5. So if I were to add 0.5, I would be saying x is greater than 5.5, and I wouldn't be including the 5. I'd start at 5.5, and the first whole number I include is 6. That's no good. So I got to subtract 0.5 from this number, and that would make x is greater than or equal to 4.5, like this. Okay? So now I'm including 5 in this estimation. And yeah, 0.5 is kind of arbitrary, but that's what it is. It doesn't really matter what you use. So x greater than 4.5 is what I need to deal with as far as the z, the normal distribution. And so I need to find my mu. That is 1,000 times 0.01. So the expected value is 10. All right. 1, 2, 3, yeah. And then the sigma, the standard deviation, is going to be the square root of those things, so 1,000 times 0.01, but then times 0.99, which is the probability of failure. So let's pull out the calculator, because maybe I could do that in my head, but I'd rather not. So 10 times 0.99 is 9.9, but I have to, oops, I'm ahead of myself. Take the square root of that. Square root of 9.9. And that is not 3.3. Don't do that. It's 3.146. And again, 3 decimal places, standard deviation. So there you go. Isn't it weird that we sometimes think, oh, the square root of 9 is 3, so the square root of 9.9 might be 3.3. That would be wrong. Wrong, 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 wrong. Don't do that. That's making an assumption. All right, so our z-score, 4.5 minus the mu, which is 10. So, and then we're going to divide by 3.146. Okay? Right? Yeah. So this is going to be, stop going away. 4.5 minus 10 is 5.5. Oops. Negative 5.5 divided by 3.146. Right, equals, divide by 3.146. And that is negative 1.748, which rounds to negative 1.75. Oh, I hope that didn't go away because I had a my phone was telling me that I only have 20% left, so I got to finish this up pretty quickly. Negative 1.75 is your z-score after you do a little z calculation with that same thing, x minus mu over sigma. So this is the probability that x is greater than, and if you remember from normal that if it's greater than, it's got to be 1 minus the probability that x is less than, right? Or 1 minus the probability that z is less than that number that I just found, negative 1.75. So I'll go to the chart for that. Negatives are this one. Negative 1.75 is 0.0401. So this is going to be 1 minus 0.0401. Negative 1.75, yeah. All right. And when you subtract that from 1, you get 0.9599. Yeah. That is a very high likelihood. Very high likelihood. And that's the correct answer, too. So what this is saying is that if my average, if I have 1% on calling and getting a sale, then if I take 1,000 phone calls, the probability of getting more than 5 sales is pretty big. It's not 100%, but it's a pretty likely thing to happen. You're going to get at least 5 sales. And that would be something you could use as a, I don't know, a boss at a calling company to say, hey, I need 5 sales from every one of you. So I know for a fact that it's a very high likelihood if you make 1,000 calls, you're going to get 5. So do it. 1,000 calls. That's what you have to do. That's your quota, right? And if you don't need that high of a percentage, if you want it more like 90%, we can kind of work backwards and figure out what number to use. But that's not what I'm asking on this. I'm just trying to show you how you can use it in real life. All right, 4, 5, and 6 are pretty quickly. You got to read it and change from binomial to the normal. That's all. So binomial for number 4 is x greater than or equal to 19. So we want to include 19 and we want to go to the right. So that means that we need to subtract 0.5 so that it's x greater than 18.5. See, for the normal, if we start at 18.5 and go bigger, we'll include 19. We won't include 18, and we'll include all the ones after it. So this is the approximation. That's what they want. And if you want the chart, you would say 1 minus this less than, Number 5, it says, it starts with binomial as x is less than or equal to 23. And so because it's less than or equal to 23, we want to include 23. Since we're going left, we need to go 0.5 over here. So we want to change this to 23.5. That way, when we start going less than, we'll hit 23 first. That's the first whole number we hit. And that's because we're including it. And then number 6, we want to go between 12 and 15 in the binomial. So with the normal, you're going to want to include 12 and 15, but on either side, you got to go 0.5 away in opposite directions. So 12 going 0.5 this way along the number line is going to be 11.5. And then 15.5 this way is going to be 15.5. And that will include 15 and 11 inside this little interval. Yep, that's what they wanted. There you go. Thanks for joining.